Hi guys, and welcome back. Don't forget to hit us up on our Facebook and our WhatsApp. We'd love to hear from you. We're here to answer any questions that you might have on 2D, 3D trigonometry. Don't forget our concept change next week. We are changing topic, so stay tuned for more info on that stuff. But for now, we're going to take a question from Precious. Let's see what she has to say.
My name's Precious and I've been having trouble with this question. Could you please help me?
Alrighty, this is a great question because it's very 3D. It actually has an object that you can try and familiarize yourself with. So let's just jump right into it. It's a great question. It reads, a flagpole AE of length 5 meters. Okay, so this is 5 meters over here. Is leaning at a 10-degree angle to the vertical AB. EF, drawn parallel to BA, check our spelling here, meets CA at F. Okay, so this here is parallel to that. An observer at C notes that the angle of elevation of E, which is the top of the flagpole, is 25 degrees. Alrighty, so that's this angle of elevation here. While another observer at D, in the same horizontal plane as C, F, and A, finds that the angle of elevation of E is 35 degrees. Okay, so that's that angle over there. It's also given to us that angle CFD is 60 degrees, which is already on our diagram. Okay, so the first thing we have to do is show that the distance from C to F is 11 meters rounded to the nearest whole number. Okay, so that's this distance over here. Alrighty, so if I look at this diagram, I see that there's this triangle that contains CF and this triangle, but neither of those triangles have enough information for me to work with. So I need to move from one other triangle into this triangle. That's what we're testing you. We're trying to see if you can find information in a triangle, translate it, and move it into the triangle that you're actually working with. Okay, so let's have a look here. We've got, because these lines are parallel here, that's 90 degrees. We can also see that because of parallel lines, the alternate angles are equal. Okay, so now we have this lovely triangle here, EFA. This is 90 degrees, that's 10 degrees, and we're given that this is 5 degrees. So now because it's a 90-degree triangle, we can use a simple ratio. Okay, so let's see. I'm going to see here that this side, let me use yellow, it shows up nicely. This side is common to both this triangle and this one. So I'm going to try and find that side there. So this is the side adjacent to that 10 degrees. We have the hypotenuse, so we're going to use the cos ratio. Cos of 10 degrees is equal to the adjacent side that we're trying to find over the hypotenuse. Therefore, EF is equal to 5 times cos of 10 degrees. Let me get my calculator out. Open this up. Okay, so we get 5 times cos of 10 degrees, and that gives us 4,92. Okay, so 4,92, etc. So that's this side that we found over here, 4,92. Okay, so now we can start moving into a triangle that actually contains the side we're trying to find. Okay, so we have C, F, that's 90 degrees, we've got 25 there. We've just found 4,92 there. And that point up there is E. Okay, so now we have enough information to try and find CF, which was this side here. This is the side adjacent to the 25, that's the opposite, so we use tan. 25 degrees is equal to opposite, 4,92, etc., all over CF that we're trying to find. If we make CF the subject of the formula, we get that it's equal to 4,92 all over tan of 25 degrees. Okay, let's stick this into our calculator again. Okay, we've already got this 4,92, so we can just divide it by tan of 25 degrees, and we get 10,56, etc. But remember, question here, nearest whole number. Okay, so that is equal to 11 meters, and that's exactly what we're looking for over there. Okay, easy peasy. Let's take a look at the next question. We've just found that CF is 11, that's 5, 10, 25, 35. Alrighty, it says calculate the distance between the two observers at C and D. So we're trying to find this here. Okay, so if I look at this diagram, the only triangle that contains that distance we're trying to find is this triangle at the bottom here, this flat surface. So we're given that that's 60 there. We found that this is 11, and we're trying to find this side over here. Okay, so immediately I see we have a side, another side, and an angle. So if we can find this side over here, we can immediately use the cos rule because we'll have enough information. So let's try and find that side FD. Okay, well, if I look over here at this triangle, I see that I have 90 there, F there, E there, 35 here, and D. Okay, so, oh, we've also been given that this here, we found here that this was 4,92 in our previous question. Okay, so now we have the opposite side. We're trying to find DF, which is the adjacent side, so we use tan. Tan of 35 degrees is equal to 4,92 all over DF, which is what we're trying to find, this linking side up here. Okay, so DF is equal to 4,92 all over tan of 35 degrees. Let's get the calculator out. Well, not that situation, this one. 4,92 divided by tan of 35 degrees gives us 7,026, etc. Okay, so now we have this triangle that we're working in. We've just found 7,026, etc. So, cos rule for CD. Okay, I want to try and get that triangle down here. Okay, no, let me just keep going. So, we find that CD squared is equal to, let's have a look-see at the triangle, FC squared plus FD squared. C squared plus FD squared minus twice their product multiplied by cos of their included angle. Okay, so I'm running out of time, guys, so I'm just going to substitute that stuff into my calculator. Okay, so remember we said that it's equal to FC squared, which is 11, plus FD squared, which is 7.026 squared, minus twice the product of those two numbers, multiplied by cos of 60. That gives me 93,07. Okay, equals 93,07 dot dot dot. But that's the square of CD, so we need to square root that. Get my calculator out again. Square root that answer, and we get 9,65. And that's that distance there. Thanks so much for that question, guys. It's a really fantastic question. Stay tuned for more stuff. We'd love to help you out. We'll see you later.
Hi guys, welcome back to the show. Remember that you can send any questions through on our Facebook or WhatsApp. We're here to help you today. This week we are busy with 2D and 3D trig. We have a great question in from Ayanda today. Let's have a look at what he has to say.
Hi Tenfold, my name is Ayanda Ajax. I'm from the east side in Heidelberg. I'm stuck with this question and I need help. Please help me.
Okay, that's quite a question, Ayanda. Thanks for that. The first time I saw this question, I was a little bit worried on my side because I don't know how to answer it. But I managed to do it, and let's have a look at what it has to say. So the first two parts are quite easy. It says, refer to the figure below, which represents the Pythagorean theorem, where squares drawn on three sides of the right-angled triangle ABC. Angle CBA is equal to theta, and the rubber band DEFGHK is stretched around this figure. Okay, so if I have to show you this figure over here, we've got the Pythagorean theorem over here, and we've then taken a rubber band and stretched it all around this figure. The first question that they ask is to write down sin theta and cos theta in terms of A, B, and C. So if we look at our diagram, theta is located in triangle ABC. So if we have to say sine theta with regards to A, B, and C, well, sine is opposite over my hypotenuse. So that's going to be equal to B divided by C. Cos theta is going to be my adjacent side, which will be A, and that'll be divided by my hypotenuse, which is going to be C. So that's quite straightforward. Let's have a look at what the next part of the question says. Write down without reasons the sizes of GBH and KAD in terms of theta. Okay, so let's locate the first angle, which is GBH. Here's GB and H. So if you want to try and find this angle, we're going to have angles around a point. So we know that that's going to sum up to 360 degrees. We know that the interior angle of a square is 90 degrees. So we can subtract the two 90-degree angles. And we can also subtract theta. That leaves us with the leftover angle GBH. So we're going to have that GBH is going to be equal to 360 minus 180 minus theta. So that's going to be left with 180 degrees minus theta. The other angle that we asked to find is KAD. So if we look in the figure, here is KAD. And we're going to do a similar thing of how we found GBH. We're going to do angles around a point. This angle over here is going to be equal to 90 degrees minus theta. So if we do the same thing, angles around a point, we're left with 360 degrees minus 90 degrees minus theta. Keep this in brackets because we're subtracting an angle with a negative in it. We're then going to subtract the other two 90-degree angles, which is going to be 180 degrees. And we're going to be left with angle KAD equal to 360 degrees minus 180, that's 180 degrees, minus, in brackets, 90 degrees minus theta. So if we simplify this a bit more, we're left with 180 minus 90 is 90 degrees, and a negative multiplied by a negative is going to be positive, which is going to be 90 plus theta. Okay, guys, so that's those two questions done. Let's have a look at the very last question. So it says here, using your answers from A and B above, show that the area of the whole region enclosed by the rubber band is 2AB plus C. Okay, so what they want us to find over here is going to be the whole area of this enclosed region by the rubber band. Let's start with the easy ones. So we can start with our squares. This square over here has a length of A, so my area is going to be A squared. This is B squared, and that's going to be C squared. If we look at the triangle in the center, it's a right angle triangle, so we can say half base times height. So that's going to be half of A times B. This other triangle over here, FCE, we can also use our normal formula for half the base times the height. That's going to equal to a half of one side, which is to be A times B. Now, the problem comes in with these two triangles over here. We're going to have to use the area rule to try and solve for them. So we already found that this angle over here, let's go double check what that was. That angle was equal to 180 degrees minus theta. So that's 180 degrees minus theta. And if I remember this correctly, this will be 90 degrees plus theta. Okay, so finding the area of triangle GHB, it's equal to a half multiplied by A times C times sine of 180 degrees minus theta. And sine of 180 minus theta is just going to give me sine of theta. The area of triangle, let's find this letter over here, area of triangle KAD is going to be equal to a half multiplied by my one side, which is B times C times sine of 90 plus theta. And sine of 90 plus theta, that's going to be a reduction, which is then going to equal to a half B times C times sine of 90 plus. It gets me positive cos of theta. Now in the previous questions, I found what sine theta and cos theta are. So if I want to add up the total area, I'm going to substitute in the ratios that I found for those. So first of all, it's going to be a squared plus b squared plus c squared plus the other two that I found, which is a half a times b plus a half a times b again. Now I'm going to substitute in my ratios for the other two areas that I found. It's going to be a half a times c times sine theta. Now if I go back and look what sine theta was b over c. So sine theta is b over c plus what I found for the other area of the triangle, which is b times c times cos theta. And cos theta had a ratio of a over c. So one more. Times a over c. So if I simplify these ratios over here, c will divide into c, c will divide into c. And if I add all of this up, remember a squared plus b squared by the Pythagorean theorem, that there is going to get me c squared. So I'm going to have 2c squared plus a half ab, a half ab, a half ab, and another half ab. That's just going to get me another 2ab. So if I factor out a 2, I'm left with 2 plus ab plus c squared. And I think that's the answer that we were looking for. There's it over there. Okay, so that's a very nice question. Thanks for that, Ayanda. It was scary in the beginning to look at, but remember, in an exam, just go through the steps one by one and see how many marks you can get, and just take your time and don't stress. Thank you for that.